context-aware smart services of LRSD laboratory. His works are mainly focuses on software architecture and automatic service management, semantic dynamic adaptation, context-aware, and multimedia documents. During his work, he has published a number of publications concerning this subject, and there is another one.
Thank you. Thank you, our Chair. Our work I titled Cloud-Based Semantic Platform for Dynamic Management of Context, our mobile ERP application. This presentation is presented by Mr. Alti, Adel, and Reffad Hamza from Algeria. Collaboration with Mr. Dr. Philippe Roose from Zika. Our presentation is organized as follows. After introduction, we will present some related work and their drawbacks and limitation. Then we propose our solution and platform architecture. We will illustrate our work by using real case study, and conclusion and some future work. We start with the introduction. Cloud computing is a model where resources are provided as services. It can be allocated on demand for users through internet. Mobile cloud computing has attracted more and more small and medium enterprises. The integration with business tool based on information and communication technology, for instance, enterprise resource planning. What is enterprise resource planning? This figure illustrates the architecture of enterprise resource planning, share database, and through automatic workflow engine. What is mobile cloud computing? Now, in the last decade, mobile cloud computing is a new paradigm that offers cloud services for mobile device for anytime, anywhere, and with anywhere. The cloud server can share several heterogeneous cloud services from different cloud providers. In the last decade, several work have been proposed, but with some drawbacks. We expose some drawbacks. This work lack of no automatic generation of context-aware ERP application, and with a massive configuration and rendered context images from profiles, with no common semantic representation of contextual information and of various enterprise resource planning. So we propose a platform that provide a semantic representation for customer and enterprise size slides. This platform provide that allows to generate automatically enterprise resource process from various cloud services and extract common contextual information and constraints of different enterprises to elaborate a common enterprise resource process. Our goal is to control and quality control and continuity of services, seamless context our digital multimedia user experience, and automatic generation of context our business process. Our work is based on ontology. This ontology provide a common concept for different cloud services, and allows also to provide a common, flexible and common representation of different heterogeneous entities. This ontology consists of 9 key concepts. This concept is, we can say it, constraint, entity, cloud provider, context, entity, enterprise, quality of services, cloud platform, context, our service, and business process. This ontology describes and details on different sub-ontology, location sub-ontology, which describes location of customers, enterprise sub-ontology, which is a key concept of our ontology. We distinguish 2 types of enterprise: production and services enterprises. Business process, which consists of a sequence of steps which performed a specific task. And also cloud provider, which can give an example of Google provider and Amazon provider. All ontology is context sub-ontology. Each context entity has its constraint. This constraint is expressed as a composition of simple context condition. Cloud services, we distinguish 3 types of cloud services: infrastructure as a service, software as a service, and platform as a service. We extend this service by another type of service, virtual service as service, virtual cloud service as service. This is figure illustrate different sub-ontology. Other sub-ontology of the 9 concepts, virtual cloud services. We can distinguish smart routing cloud services, monitoring as a service, scheduling as a service, planning as a service, migration as a service, federation as a service. Quality of service sub-ontology, we distinguish which is a set of quality of service parameters like execution time, security, and so on. Entity sub-ontology or resource sub-ontology, it is input-output of a business process. Contextual sub-ontology, we define 4 types of context sub-ontology: environment, quality of services, equipment, hardware, and user profiles and preferences. Functional model of the platform. At step 1, the inference engine cluster common needs of a different enterprise constraints. If no similarity, we go to step 6. In the step 2, the inference engine uses inference rule for matching between different contextual constraints of enterprises to extract the common contextual constraint of different enterprises. In the last 3, we try to find virtual cloud services that response of common virtual contextual constraints. Then we generate an optimized virtual business process. This step consists in constructing all possible composition between individual virtual services based on a list of virtual services of step 3. we refine after several steps of refinement of business process. We can elaborate a specific business process for each enterprise. We select a quality business process and that answer the different user preferences and constraints. Finally, we call each cloud service and send the result to customers. This rule define how to extract common contextual constraints of different of several enterprises. I try to elaborate, to generate automatically virtual business process from a common contextual constraint. Our objective is to accelerate the development process of enterprise resource planning by extracting a common contextual constraint and then to refine the virtual business process to several specific business process. To illustrate our approach, we propose a real case study of two companies, Sensei company and Agrofin company. Each company has its constraint, specific constraint. At the first step, we try to extract common needs of different of two contextual constraints. Then we elaborate automatically when obtain the common constraint of two different contextual constraints. We elaborate virtual business process, and with the specific needs we elaborate two business process. With the mobility of a user, we try to provide the user an appropriate service for each situation. For example, in the home, we try to find an appropriate service that work in smartphone, smart TV and laptop. When user in a car, we try to change a service with another service, and in the office we try to continue to deliver an appropriate service when in its office. In order to validate our work, we develop a simple prototype that illustrates our work. In the first step, we look for a company and its business process. Then we try to provide a virtual process task, and finally we provide by using inference result each specific business process for each customer. Conclusion: design and context our deployment of WebP mobile app business product that combine three technology: semantic web, cloud, and middleware, offer unique, conscientious, interactive experience to the customers. Leveraging of semantic knowledge on the side of the enterprise to collect and process live business context management and accurate feedback, which can significantly help them improve the offered service and continuity. And a first attempt on conducting scale experimentation on unique technology facility to progress the concept of the future WebP enterprise resource planning internet using heuristic parallel semantic genetic method at runtime phase. Thank you for your attention.
Question? No? I have two questions. It seems like your sub-enterprise ontologies are for specific subdomains, right? How do you consider to integrate other ontology? It is possible in your approach to integrate
to be efficient and interoperable between different and heterogeneous cloud services. We propose to use a high-level core ontology, and we can extend the core concept of the high-level ontology to other specific concepts of other domains.
Okay. You said that you will produce automatically context-aware
mobile application.
Mobile applications, and this automatic generation is based on the
references rule.
On the rules.
References rule.
And the rules are predefined.
Yes, I predefined generic rule and a specific rule. Generic rule that permits to extract a common contextual constraint. Specific rules to generate interactive cloud services for each customer.
Okay. And which tools do you use for the demo?
With two companies in our city. There is we take two companies of our city with existing Replay application, and we try to elaborate a common ERP application for management of fire or to access the development of several ERP applications.
Okay, and the generation it's in which language?
Language I use NetBeans for NetBeans, yes, Java.
Okay.
Thank you.
There is no more question? All right, thank you. It's for you.
Thank you. Thank you very much.
Okay. Now, it's the call for Sarah Zenasni. She's currently a PhD candidate at the University of Montpellier, France, at the Laboratoire of TEDIS, Territoire, Environment, Remote Sensing, and Spatial Information in Computer Science. Her thesis is funded by the Minister of Higher Education and Scientific Research of Adel.
Thank you for the presentation. First of all, I will apologize because I'm a little bit sick, so I will hope that I will not disturb you. So today I will present our work, which is focuses on the extraction of new kinds of spatial information from textual from short messages. I will start my presentation with the classical plane, which starts with the introduction on spatial information. Secondly, I will move on the main issue of our presenting work. Then I will present our method, which is divided in 3 main subsections. After that, we will take a look at the results of our experiment, and finally, I will finish my talk with a conclusion and some perspectives. So, firstly, we will take a look at the importance of extraction spatial information. Spatial information extraction is an important task in order to facilitate the search of information, to supply and deliver information, also the control and thereby the improvement of the using of the information, importing store locations, commercial and business interest, and countless other services. So extract and analyze spatial information based on the various types of data sets as maps, satellite image, GPS, and textual data. Recently, text have become an important data resource. A lot of web pages contain text, digital version of book, report, articles, and electronic newspaper contains spatial information. Here, an example contains spatial information. So I will read this in English. Saint-Guillaume-le-Désert Hotel, located in Anion, 25 km from Montpellier. Gary Miner estimate that 80% of information available in the world are in free text format. So extracting spatial information from this data is important in order to discover domain-relevant information in the text, improving document search and retrieval system, transforming text to more structured data, and analyze this data. So in addition to this standard data, electronic written text used in mediated interaction, especially short messages as Twitter, SMS, Messenger, and other short message services, have triggered the emergency of new ways of writing. So an example here to present spatial information in SMS, fresh SMS. So, hello, we came to Montpellier. So here the word Montpellier represents the spatial entity Montpellier. So here we want to extract first the spatial entity, the new variant of spatial entity Montpellier, and after we want to extract a new spatial relations as Sur. So extracting spatial information from this data is highly important in order to benefit from the vast amount of geographical knowledge expressed in variant kinds of document. Fusion of extracted information from multiple kinds of document and source, analyze and provide intelligent navigation method, enriching spatial information, and improving management and intelligent mechanism of event management system, emergency rescue system, and recommendation system of tourist places. Short messages are informal as the communication based on the rapid exchange of information. So the main issue of our work is that these short messages are brief, unstructured, irregular, and in informal nature. Also the multitude of different expressions of the same entity, for example Montpellier, Montpellier. Also the non-standard form of the language of short messages. And all this make the analysis of the information difficult since they are different in many ways from other kinds of corpora. Yes, so the objective of our work here is to extract new kinds of spatial entities and relations written in short text message language from two authentic French corpora, SMS and Now I will move to the next point of my presentation, which is presenting our method. So we propose a process in which firstly we identify which we call it standard spatial entities from short messages. Then we will try to enrich this list of standard spatial entities with new forms of spatial entities, which we call it variant spatial entities. After that, we will propose a method to identify new spatial relations. And finally, we will try to propose a general pattern for spatial relations. Okay, let's start by the first step, which is identification of absolute spatial entities. So we extract standard spatial entities as Valence, Montpellier, Béziers, using an initial dictionary of standard spatial entities. Then, as a second step, we propose a method to extract a new variant of spatial entities as Montpellier, Béziers without as an accent. So first, we calculate the similarity between an initial dictionary of spatial entities and all the corpus of the SMS using linear measure, which is based on n-grams of characters, and string matching measure based on Levenstein and others measure. This measure calculate the lexical proximity between two strings. And then we determine the closest word in terms of threshold of similarity score in order to select the most relevant variant of spatial entities. The example here shows the similarity obtained using string matching. We use string matching as it gave the most relevant results. So we calculate the similarity between the standard spatial entities Béziers and the word Béziers, which is new variant of spatial entities. According to a string matching measure, we obtain score equals to 0.66, which is a low score. And we calculate also for the second example, we calculate also the similarity using string matching between the absolute spatial entities lat and the word pat, according to which is less. According to the string matching, we obtain a score with equals to 0.83. The two words are close according to string matching, but with a very different meaning. So, in order to reduce this, reduce the ambiguity identified in this step, we propose to combine similarity measure with lexical analysis. So, as a lexical analysis for the first one, we propose to utilize an accent method, which is the absence and the presence of the accent. After applying this method, we obtain for the first example, which is Béziers and Béziers, a score equals 0.83 instead of the first, which is 0.66. And we note that the user uses always the same prefix in order to make the information more understandable. So we assume that the two words that don't start with the same prefix do not represent the same entity. After applying the second lexical analysis, we obtain similarity equals to 0 instead of the first time, which is 0.83. For the second step of our method, which is identification of a new spatial relations, here we try to identify new spatial relations in short text messages as sur and par. So we label the corpus using Teisseire. Then we calculated the number of occurrences of label of the word precedent spatial entities. After that, we assume that words associated with the two most frequent labels are variant spatial relations, are candidate spatial relations, and finally we select the most frequent words on the basis of threshold. So to understand this method, an example to understand. So first, we label all the corpus with we use Teisseire for labeling the corpus. Then we calculate the similarity. We calculate the number of occurrences of the label and the word precedent spatial entities. After that, we select the word. Sorry. we select the word, the two most frequent labels, sorted by the number of occurrences of each word. For example, for this example, we select the two most frequent labels, preposition and noun. So we select all the word of this these two labels. Then we sorted these words by the number of occurrences of each word. And finally, we select the most frequent words in the basis of threshold. To enrich the first list of spatial relations, we apply the same process of the enrichment of spatial entities, which is we calculate the similarity and after apply an accent method to identify new forms of expression of spatial relations as pre without accent, also quote without accent, because in the SMS, in the short messages, the people doesn't take into account the accent of the word. And finally, we select the post-tagging of words which are between the spatial entities and spatial relations. Then we select the n-grams of word which is included as the first word spatial relation. And finally, we propose a new pattern for identification of spatial relation. For example, we select the two spatial entities Montpel and the spatial relation Pré, and we tag the noun, we label the noun, the words between the two arguments, and then we add it as we add it to identify a new pattern of spatial relation. To carry out our experiment, we use two French authentic corpora. The first, which is 88,000 SMS, is a French corpus, which include more than 88,000 of SMS in Montpellier. The second corpus, tweet corpus, contain more than 1 million tweets, which more than 800,000 are in French. Also, we use two dictionaries. The first one is Spatial Entities Dictionary, which contains more than 8,000 of geographical elements, and Spatial Relation Dictionary containing 163 of spatial relation. So, for the first part, which is enrichment of absolute spatial entities, we calculated the precision, recall, and F measure on the a sample of 1,000 of SMS and tweet. So, after apply the lexical characteristic, after combine the similarity measure with lexical characteristic, we obtain in terms of macro F measure 0.87 instead of 0.46 for SMS, and for the tweet 0.86 instead of 0.51. On sample of 1,000 SMS, we was able to identify 46 standard absolute spatial entities and 21 variant spatial entities for the SMS, and for the tweet, 67 standard spatial entities and 23 spatial variant spatial entities. We use as threshold with the threshold equals to 0.80. In this step, we test for 0.6 to 0.9 for the threshold, and we obtain the best results with the threshold equals to 0.8. Here an example for the first is basic similarity, which just we calculate the similarity. So for the absolute spatial entities lat was associated with the words pat, mat, and so on. And for the second one, Bézier, was just associated with Bézier without accent. So after adding the lexical characteristic, the absolute spatial entities last was only associated with the lat without s, and for Bézier was associated with Bézier as the first, but also with Bézier without s and without r. So in this case, we improve the in the precision and recall in our method. For the identification of new spatial relations, we obtain the best result with the threshold equals to 2. So in terms of precision, we obtain 0.88 for the SMS with the 8 relevant relations. And for the Twitter, we choose the threshold equals 2 instead of 5, and 5 give best precision because of the equals to identify 5 relevant relations instead of 3. So for the identification of a new spatial relations, we identify 2 types. The first one is recognition of new spelling, which is the initial relations without or with the accent, and also we was able to identify a new vocabulary of spatial relations as sur, par, devant without e, and avant, which is more temporal relation. And we select as a new pattern spatial relation with preposition. So, as a conclusion, we identify or propose a method for the automatic identification of a new variant of spatial entities and relations from 2 authentic French corpora, SMS and tweet. Our results highlight a significant improvement of identification of a new variant of spatial entities. And also we show that combined different approach improve the quality of identification of spatial relations. As perspectives, as we see, we didn't detail the extraction of new patterns of spatial relations. So we will try. We want to use a new ranking measure, C-value, to select the most relevant spatial relation syntax. For example, choose côté de préposition or à côté preposition. Also, we plan to identify new semantic relations between 2 spatial entities as capital or twinning. And finally, we want to identify spatial relations between 2 named entities, for example, person and organization. Thank you for your attention.
Okay, any question?
Yes, I have 2 small questions.
Yes.
You said that your corpus had 8,000 French SMS?
88,000, yes.
88,000.
More.
How did you know that? How
Because
did you come to this conclusion?
what that there is 88,000 SMS because it's collected by a group of just.
I'm just curious.
Yeah, sure.
I'm not doubting that.
Yes, yeah. We it was collected by a multidisciplinary team of linguistics and
okay.
computers. So we use the SMS, which is more than 88,000. It's them who give the number of the SMS. Yes.
So they didn't check every single SMS, I guess. That's my question.
Yes, for us, we select 1,000 because to calculate the precision under recall, it's not easy to read all the 88,000 and validate it. So we select 1,000 of SMS and 3 annotators who read and validate our work.
Okay. And did you consider treating the accents in French as half, like, I guess, in your analysis of the accents, you either had similar or not similar.
Yes.
Could you treat it as semi-similar, like half similar to like an unaccented character could be half similar to an accented one? Like, to take your example from lat and pat, this is really different, L and P. But E and P with an accent could be said to be half.
Yes, but we use a similarity measure which already exists. There is lean, string matching, and other measure. So this measure we applicate it, and they give us these results. It's not the same. So what we do, we add an accent method to say that if there is accent or not, it's the same for us. We calculate the similarity as E with or without accents is the same. It's same character.
Do you think it would be helpful to treat it as half similar, or?
Yes, if there is a method who will do that, in the best of my knowledge, I don't think that there is. But if there is, it will be easy to add and to do it. Yes.
Thank you.
Another question? No? Okay. It will be difficult to use your approach with another language. I mean, not with French. Maybe we only have to change the ESE dictionary, or it should be more modification.
In English, we want to because we tested with a more standard corpus, which is a newspaper. We use our approach, and it gave relevant results, good results.
Okay.
So we will try to adapt it with English, but we don't know if it's work or not. We didn't do it. So, but I don't know, because first in English there is no accent. But it depends in the short messages, because people just write as they want. So we are not sure if they use accent or not. And also, yes. And for the second, what we added, that we cannot just consider the similarity. I think even in the English, we should to see if they start with the same characters, or I don't know, but we should test it. Yeah.
Okay. The final question about the quality of the results. I mean, because you said, okay, we get some percentage of accuracy. It was compared against human perception.
Yes, so here we give to 3 annotators, which read the SMS, the 1000 of SMS, and they extract the spatial entities from this SMS.
Okay.
And after we compare what our method extracted with what they extract to calculate the precision and recall and that measure. Okay. Because it's the only way we cannot know that.
Because you didn't.
Yeah, as a result, we don't have any idea. Yeah.
Okay. Okay. Is there any question? No? Okay. Thank you. Your certification. Sarah?
Yes, okay, sorry.
Don't go.
Sorry.
Thank you. Okay, next presentation. It's Edgard, Costa, and Almeida. He's professor in University of Brasilia. He's software engineer. PhD and master got his PhD and master degree in information science, and he's currently doing a postdoc research on ontology-based text algorithm in cooperation with University of London.
Hi, thanks for receiving me here in this congress. I am presenting now a didactical experience of gathering 2 groups of students from computer science and software engineering of the University of Brasilia to help to foster the learning of semantic web approaches and technologies. So we are presenting the result of this 1 semester work with these students. and we proposed the design of an ontology-based authoring environment, the production of texts by using ontologies to help authors choose the right terms to represent that text or a news text produced inside newsrooms environments. And the domain that we used was the Zika virus domain, which doesn't have ontologies about it, and it's very popular issue and very dangerous and problematic medical and health issue now in Brazil. This work has been done with cooperation of software engineering and computer science courses, and with the supervision of Professor George Guinea of Brunel University. And I have to give thanks to Capes and Finatec for financing our project and our travels. So our main motivation was that we are doing this project and this teaching under the umbrella of the research project of multimodal digital media, which is seeking to understand the phenomena of convergence in many senses in the newsrooms of newspapers. So we proposed teaching semantic computing for undergraduate students of computer science and software engineering courses. Computer engineering is together with computer science. And we are here showing the results of this experience of having students researching and us teaching conceptual and practical basis for the specification and modeling of and design of an ontology-based news authoring environment for the semantic web, and using the domain of the Zika disease. So as an introduction, we are making reminding that text authoring as of today is quite similar to what's been done 100 years ago. So we have pen and paper, or we have word processing, white page and cursor and keyboard, and users and authors are there completely alone to input information the way that they feel like inputting. So this is the main problem of unstructured information on the web, and this is also a kind of approach that we lack considerations on the literature worldwide, which is how to help people structure their texts at the moment the text is being produced, not after the text is being published and already written and revealed and already decided what has to be done. So computing always has to run after solutions for post-production issues. So of course we have new features involving this environment, such as natural language processing, information extracting, reviewing capacities, hashtagging, and so on. But still, all this is done syntactically, and this is also done post-publications, at the moment of post-publication, and for already published resources. So our main issue is it possible to help structure information semantically at the moment that it's being produced? So this is part of my PhD research that I did some time in the past, some decades ago, that I'm getting it out of the drawer now, and quite sad that not much has been done about it, except for semantic wikis, which are the main inspiration for our worlds. But we are trying to design this for CMSs, trying to apply a semantic layer on top of CMSs for newsrooms. So the semantic web is this opportunity to pursue concept referencing via terms or via other kind of objects from and to texts. Not only its objects and components such as summaries, images, links, and descriptive terms and their meanings, but semantically representing these resources. We know that by nature content is generated by one person, indexed by another person, and retrieved by computers that have no idea what we are talking about. They are there with their algorithms trying to interpret in the most complex ways the easy things that were put, easy for the writers, that were put on paper, on the texts. So why not help writers, authors, structure semi-semantically their texts with the use of ontology at the moment that the text is being produced or is being published? This is our Harry Potter idea of getting structured, ontologically structured texts that we are trying, not yet developed, but we are trying to create the culture to research this subject. They're in our alone isolated group in Brasilia. CMSs are the leading environments for text productions everywhere in the world, particularly the biggest producers of published and worthwhile, trustworthy information, popular information are the newspapers, apart from scientific media, of course, scientific content. And CMS is mostly used worldwide, we are researching. Some examples are Newsgate, Escenic, Shalok, Gen3, Dateline, Publica, DA Press, Good News, Digital, and Graffiti. Each one particularly being used by one or another newspaper. I think, I will show you the scope of our research. So CMSs offer, at most, keyword extracting from natural language processing, metadata recognition, but still has to be validated by the user at the moment that they extract. Semantic Media Wiki also lacks the use of ontologies to give consciousness to users about variant terms at the moment of production, and still it just gives metadata support for representing information after published. So this is one of the limitations that we want to overcome. Of course, that authors need to count on some kind of controlled vocabulary as indexes for information precision. Of course, I want to use the term that I use in my context, but if I am aware of the variation of that term in other contexts, or where that term or that concept is positioned in the scheme of things with the help of an ontology visualization, this would help a lot information precision and the structuring information and so on. So, ambiguity and unprecise referencing and tagging is visible to us all users of news websites. You are checking news, and then at the end they suggest the most weird connections to other subjects that are not really related to that particular subject. Either they use a term, a similar term that in another context means something else, or they have absolutely no linking to other upper or lower concepts. And the combination of terms is not really clear to users. So this is one of the main problems that we want to overcome. Our research project is studying news authoring tools from La Nación. We've already visited the La Nación newspaper in Costa Rica, which is one of the main examples of newsroom information management in the world. The BBC that uses the graffiti tool and uses domain ontology just to structure metadata, but it doesn't use domain ontologies for helping users. We're going to visit now the New York Times and the Guardian. We already visited the Globo in Brazil, which is one of the biggest newspapers also in the world, with a high range of access to people all over Brazil, and Correio Brasiliense, particularly in Brasilia, due to our physical proximity. So we are searching via these study cases to understand what are the practices being done in these newspapers. And of course, that we saw that none of them use this kind of approach of using ontology to help index information and to help authors at the moment of production to be conscious about the variation of terms, and also to use ontologies to refine and to help use more precise words for indexing. Of course, we chose the Vicazeiros disease theme as a domain because of its top of the lines. Due to a lot of ambiguity also in the use of the term, and there's absolutely no ontology being created for it, except Nomad City has some entrance on Zika as a last instance of a disease structure, and due to the epidemic status of the Zika in Brazil particularly, and some African countries. So our objectives are to present the context of the solution design, its motivation and proposals by indicating a semantic and computational platform designed to receive the solution. We still don't have the solution. We're still validating the possibility of using this infrastructure to create the solution. We created already a first version of our Zika ontology and the process of creating it, and a general model of the architecture and the support of authoring environment via semantic CMS. So the main issue here is how to prepare a critical mass of students that can help us design a solution. This was the challenge that we brought in this advanced computing course in our software engineering and computer science departments. So main proposal of the tool is to annotate terms and concepts used by writers, journalists in this case, and to relate these terms with the ontology of that subject. So the user would choose which ontology he intends to use, or this ontology can also be automatically brought out to the user at the moment that he is creating his writing environment. And to relate this, and to create links with other information resources in that limited environment. In the case of a CMS used by a particular newspaper agency, we want to make references with already published material about that particular subject. And of course making the right links and the semantic links with existing news pages and other pages selected by the writer. So we dream of this tool. So our project team briefly, so we based our specification of the environment from my PhD thesis. So I was very happy to have these guys, that this was possible, also believing on that dream. The main requirements were designed 10 years ago with the help of Professor Frank van Harvelen from Vrije Universiteit in Amsterdam, where I did part of my PhD. And we believe it's still valid in some issues, others we of course need to update. So we had a collaboration of 15 undergraduate students and three professors of the University of Brasilia. I am from information science. I'm not a computer science specialist. I'm wondering about and understanding as much as I can, but I'm working much more on the requirements specification from the side of the user, while my colleagues are working on the computational solution. We counted with a group of medical staff from the health department of Brasilia to help design and the domain of the Zika ontology. And the users of the solutions are the journalists of the Faculty of Communication, and this is where we want to test the solution, is on the campus online newspaper of the University of Brasilia. The groups were divided in three parts. We had an environment specification team, conceptual modeling and ontology construction team, and requirement specification for software development. We taught when we leveled this content basically among the students, XML, RDF, and RDF schema, OWL for the Zika ontology, Python and RDF lib, which were languages close to their already acquired backgrounds, Sparkle, and Apache Jena Fuseki. For the Zika ontology construction, of course, we made a first research and there was a total lack of ontology about Zika. Of course, this is a new disease and this justifies it. But it's urgent that we develop this ontology as soon as possible. The medical team has an input for the conceptual modeling. We used 101 methodology, CMAP and XMind tools as modelers, main modelers, as a tool that is also easy to use and interpret by doctors, not just information architects. We used Web Protege as an ontology editor. This is the part of our conceptual map. It's invisible, of course. It's still invisible because it's in Portuguese, and it shows some basic relations between the terms that we used to model the world of the Zika. That ended up in this visualization of our first view of the Zika ontology. We designed a process. Of course, there were software engineering students. They had to model and to define the right artifacts to be done, and we had a lot of tools to help us support this task. And this is being done again in the undergraduate level. So we really have to pave the way for them to do it by using Kanban, Trello, and Slack, Group, and Scrum in a hybrid approach. They produce general artifacts like architecture documents, glossary, iteration plan, and vision documents. Design the project phases and the vision documents of the main scope, and an architecture to refine the scope. Our main solution, as designed by the group, is structured in three areas. Those are three areas: visual logic and processing and databasing. So basically the user visualizes the screens, makes queries to the program and processes the queries from data from the base, and the solution returns the data that is interpreted by the application and shown to the user. So we kind of try to put each part together, working with structured information and non-structured information. So our prototype is now being developed in this present semester. So we are using Python, we are using Linux free software operating system. We are using Apache to configure the HTTP server, RDF-lib, which is handling RDF and XML data and querying with the Sparkle, and using Django to simulate the SMS. And basic feature is a window of the document edition presented using Django, second window showing the RDF graph, which is the ontology structure, corresponding to the semantic annotation recognized in the text, and a final window showing the related documents from the newspaper domain, searched based on the edited documents graph, RDF graph generated. So the general model description, it's not that clear, it's still, we used and we valued our students' efforts, but mainly we have an application database coming from the domain ontology that was defined in the context, it's the Zika. While editing a test, the platform recognized the terms edited via annotation with the system RDF for J. Joint engine application also used, and they use servlet Java that interacts with Apache Tomcat and Apache Stumble. The Stumble is one of the solutions designed by IKS, the Information and Knowledge Stack, that is the first approach that we found in the world to semantify CMSs. So this is also one of the main architectures that we are using. The document treatment and information retrieval dynamics is based on the recognition of classes and instances of the ontologies, which are matched with the text in order to support the annotation process. And while the text is being written and the annotations are made in connection with the OWL ontology, then making the semantic annotations and thus extracting a subgraph. The idea is that we create a sub-ontology of that document, that we can take pieces removed from the ontology, of course, copy parts of that ontology like a jellyfish, and then you can have the ontology of the document, so that document could be semantically represented. This sub-ontology then is used to generate specific and context-aware keywords particular to that document that was produced, as well as to hyperlink it with other strictly related texts and that are similar to that one in context. So our conclusions are that we still don't have that environment. We hope to have it as soon as possible. That's why we are bringing it out to discussion and to opinions. So we have the architecture model for our prototype of a semantic CMS that represents this effort and the practice of students and professors that is still under development. Our undergraduate students show the capacity and advanced abilities to deal with these challenging issues in a computer science environment and software engineering environment as well, even though they were not familiar with some of these technologies before. So they were really challenged and they really adhered to the proposal, which was really interesting as a motivation, and we need a lot of motivations for undergraduate students, as you know. So we have a proposal and a specification, proposal of specification modeling still under critics of this authoring environment for a text editor based on CMSs that supported by a semantic and lexical interpreter for the edition of news articles about the Zika, supported by a specific set of ontologies, top or bottom ontologies of the domain. The main difference from our approach as a conclusion is that we use ontologies mostly for post-publication to enhance information retrieval processes. We use ontologies. We pretend to use ontologies at the moment that information is being produced. So we also showed that it is possible to implement the solution. Yes, we think it is possible. Not yet identified in existing CMSs available. Due to the scope of our project, we ran through all these CMSs and we found a similar approach. And we hope to enhance then the existing CMSs and future CMSs with these new features. Merci beaucoup. This is my contact.
Any question?
Yes, thank you. It's very interesting what you are working on. You mentioned about your experience perhaps with the Semantic Media Wiki, and you were describing a few elements like the difficulties for annotation. We have been working a lot with Semantic Media Wiki and with specific extensions using semantic forms, and also having RDF store, to validating the solution in the collaborative work. Your solution, I think, is very interesting, but I was wondering how easy it is for the users, because Semantic Media Wiki is based on Wikipedia. I mean, everybody knows Wikipedia.
Yes.
But in your solution, how easy is for the users to really collaborate, to really produce information if they are not experts in ontology? How easy is annotate and produce documents?
Yes, we didn't put it on the paper, but I can show you a screenshot of our first design of that solution, so you can get an idea of how easy it could be. I was waiting for this kind of question. And this doesn't precisely show the rest of the solution, but the idea. Oops. Oh, I have to. First, I have to do this, I think. The idea is that you have a text editor as easy as it can be in the world of the user, that he has a complete domain. This happens here on his own page that was previously recognized on the ontology. But he can see the ontology and he can locate his terms in the scheme of things. And he acquires knowledge at the moment that he knows what he's talking about. And he can, by these terms being recognized, he can immediately, on the closed world where he's having his text referenced, he can also validate if the links that are being made to his text are really semantically related, relevantly related. So the idea is to perform something like this.
Okay, and there is mainly object properties, or you are also having data properties in your
mostly object properties, yes,
okay.
To make it as easy as possible, as simple as possible. Yes, and this will also popularize the use of ontologies, bring ontologies closer to final users, because ontologies are huge sources of knowledge acquisition, as we know. And this would help people also populate ontologies by suggesting new links, or ontologies will be able to automatically grow out of these new combinations. Users from their own intelligence will be able, I don't know how yet, there are some research being done about it, how to automatically create ontologies out of texts
and
entity recognitions.
Are you able to identify inconsistency, or how you are validating that in real time? Or
We are considering these issues yet. We don't have solutions for that. Maybe Sarah will be able to help us on that ambiguity recognition, but we use basic natural language processing to identify ambiguities and inconsistencies.
Thank
you for the presentation. Please, how you can create semantic ambiguity in your ontology, in your approach? Semantic ambiguity.
How can you recognize semantic ambiguity? Yes, by representing the ambiguity in the ontology. The ontology will be the source of the ambiguity, like we are doing with the Zika. We are referencing all the synonyms and hyperonyms and the antonyms of the domain of the Zika.
Any other question? I'd like to know your experience about the different ways to define an ontology. Do you think that the methodology that it is used to define the ontology will impact the final ontology, or it should be independent of that?
I think so. I agree with your first part. I think it depends on how you present it and how it is being done. It depends how deep you develop the ontology as well. If it's a top-level ontology, it's much easier to be enhanced.
Yeah, okay. The other is more for software engineer point of view. The three groups are working independently, or there are some?
No, they are being coordinated by the three professors. Yes.
But there are not people that work in one group and in another group. I mean, intersection and
there are. They work in one or more groups. Yes, that's a good question. We put students also to model the ontology and also to help on the software engineering part. Or he's modeling the ontology, but he also has some computer science skills to define or to study the implementation methods. Yes.
Okay. Well, thank you very much. Okay.
Thank you.
Right. This is your certificate.
Thank you very much.
Thank you. Okay. Now the last presentation from Fernando Ferri. Fernando Ferri received a degree in electronic engineering in 1990 and a PhD in medical informatics at University of Rome, La Sapienza, in 1993. He's senior researcher of the National Research Council of Italy since 2001. He has researched from 1990 to 2001. He was contract professor from 1993 to 2000 of Sistemi di Elaborazione at the University of Macerata. He's author of more than 230 papers on international journal books and conference. He has coordinated and participated in several national and international research projects. He has organized several international events, scientific conferences and workshops. His main research areas of interest are social informatics, social computing, data and knowledge bases, human-machine interaction, user-machine-natural interaction, user modeling, visual interaction, sketch-based interfaces, geographic information system, risk management, and medical informatics.
Well,
Okay.
okay. This paper I present today is the result of a project partially funded by the Italian Ministry of Research, and it is in the context of a public-private consortium that is based in the south of Italy. The name is Innoval. The paper, the authors are I, Patricia, and here, and other two engineers that just joined our group in this year. My presentation is as the following, as this outline. First of all, I'll present the problem and the aim of the paper. Then I'll give you an overview of methods for fall detection. Then I'll talk about the challenges in fall detection, and then possible solution, the solution we studied and we implemented to address the open challenges, and then I conclude and I'll show you future works that we think for improving the approach. First of all, the problem. We have to consider that the falls are the fifth leading cause of death for. So it is a relevant problem, especially for senior citizens. In particular, the World Health Organization calculating about 28-35% of people aged 65 and over fall each year, and about the 32 from 32 to 42 for people over 70 years. So obviously the injuries suffered depend on the kind of fall, but in any case it is very important to detect immediately the fall and provide a rapid, quick recovery of these persons. For solving this problem, the aim of the paper is to define a fall detection methodology based on multiple sensors. In particular, in our approach, the main idea is to use those sensors that are largely available. These sensors are those we have in the smartphones, and in particular in the smartphones there are several sensors that can help to detect the falls and can provide a rapid management of the emergency created by the fall. Regarding other past studies, we can divide in two main approach. The first approach concerns the use of ambient sensors. Another approach is to use mainly the wearable or the smartphone sensors. In particular, the first approach is based on we have several experiments, for example, for floor sensors, microphones, infrared sensors, cameras, microwave, motion detector, and so on. The second kind of approach for wearable and the smartphone, they are mainly based on accelerometers and in some case gyroscope or the two sensors integrated. These ambient sensors are very useful when we have people with reduced mobility. So I have an environment in which this person lives, and I can monitor this environment. And moreover, it is possible also to do a strong personalization based on the specific context and the patient to monitor. In the second case, the monitoring concerns both indoor and outdoor context. It is good also. It is good for people that have good mobility, and this kind of approach facilitate independent life for the elderly people. Obviously, in this context, the operative conditions are broad, so and they can influence the performance of the overall system, because obviously indoor or outdoor the conditions are different. But we want to consider this problem, the problem of falls, not only as a problem of detect the fall, but we want to consider this problem in the context of a digital ecosystem, digital healthcare ecosystems, in which we have several kind of people collaborating, because the problem of a patient is not only a problem of the patient, but it's a problem of the family of the patient, of the friends, and so on. So in this context, also of obviously of the family doctor, obviously in this context, any person can collaborate for the recovery of the patient for the after a fall. And the sensor have a very important role, because they are the activator of the process. When this kind of sensors detect a possible fall, it is activated a procedure for understanding the status of the patient, and if the status is ambiguous or there is the possibility of a fall, there are several steps to verify the patient condition. Regarding the sensors, many past works considered the sensors applied directly on the skin of the patient, or on the wear or shoes of the patient, because obviously these kind of sensors are specifically designed for this application, have a condition completely manageable, and are completely follow the movement of the patient. Some works considered the sensors on the smartphones, in particular the accelerometer and the gyroscope, or both. Some cases also both. But the problem with these two, with the sensor in the smartphone, is that the two systems, the patient and the smartphone, have different conditions. I can have my smartphone in the pocket, here. I can have in the end, and so on. So there are different conditions that influence the capability of the system to recognize the fall. So we have to consider different conditions. Moreover, when I fall, there is also the problem that I don't know where is the smartphone after the fall. For this reason, in our experiment, we used 5 different sensors in the smartphone. Obviously the accelerometer, that is the most important, the gyroscope, the proximity, the microphone, and the GPS. Obviously, all these kind of sensors have a different relevance and role in detecting the fall. In particular, the accelerometer is the most important, because is the sensor that activate the procedure to test the other sensors, and for creating an alarm. So, in particular, a fall has this. When a fall happens, there is this particular signal for the acceleration, because there is this is 9.8, that is when the patient is not in movement. There is a peak under 3 before, and a peak under 14, 15, just in a very small interval of time. So the accelerometer try to acquire this kind of signal for starting the procedure. So we did several tests considering these two kind of interval for this for the minimum and this for the maximum, for understanding what is the best threshold to consider. And we test also with different sample frequencies, mainly for considering the energy consumption, because obviously if we have 12 samples for second, obviously I have energy consumption. If I have one, I have a smaller energy consumption. And after several experiments, we determined that the best compromise was for 6 samples per second. And this the minimum and the maximum happens in the range of 4 consecutive samples, usually in this. Regarding the gyroscope, we have the same number of samples, so we consider the same number of samples. And in particular, it is important that in the first 5 seconds that include the interval of the fall, we have this event that the angular speed is greater than 340 degrees per second. We have also evaluated to introduce in the second part, because our interval is 10 seconds, and we considered also the possibility to have in the second 5 seconds after the fall, probably the patient is in the ground, and probably if the fall is particularly grave, his problem is that it is immobilized. So the second in the second 5 seconds, the angular speed should be for all the 5 seconds lower than a threshold, probably. But this kind of part will be tested with the real patient, because for the moment we tested the overall system, considering laboratory tests with people that simulate the falls, obviously, because the falls is a frequent event, but not so frequent with a small number of people. The other three sensors, the proximity sensors, have to detect mainly the change of the status. So in this case, the proximity sensor detects that the smartphone is in my pocket and has a contact with my clothes. If there is a change, for example, the smartphone fall not together the patient, the change can the status can change. Also, in this case, for a complete evaluation, we have to consider a large test with the patients. The microphone analyze in the interval of 10 seconds the signal of the microphone, and in particular the idea is to analyze noise, shout, laments, and so on. We tested for the moment the noise. For the other kind of signal, obviously it is necessary a large test with the patient. Finally, the GPS is mainly used for acquiring the position of the patient for starting the procedure of recovery. These are the experimental tests mainly. The tests have involved 5 people for simulating 100 falls for a total of 500 falls. Moreover, we also test the system involving 10 people for 10 days for detecting false fall. So, for example, a person that sit rapidly on for having data regarding this aspect. Obviously, the data mainly consider the signals of the 5 sensors, but we did a specific tuning for the accelerometer, considering also the other parameters detected by the other sensors. And these are the results. After considering the result, we decided that based on the tests, the better couple of threshold was this, because with 315 we have the accuracy at 89%, and that is a good compromise with the specificity and sensitivity. In general, the result we obtained are promising, because we obtained a result very close to those that applied the sensor to the skin or on the cloth of the patient. Obviously, we think to improve this result mainly considering tests with a real patient for adapting all the parameters to the specific patient. Because obviously, and we also can consider in this case how the different thresholds interact. So, because it is possible not only to choose what is the best situation for the accelerometer, but we can provide different kind of solutions in the combination of the different thresholds. I concluded my presentation. Thank you for your attention. The main references.
Okay, is there any question?
Is there a way to distinguish when someone holding a mobile phone falls or when the mobile phone falls from the table?
Yeah.
You can distinguish between these two?
Yes, there is a very different situation. It is the situation that is more ambiguous is the person sit rapidly. It is the situation that create this a possible ambiguity, but not if there is the smartphone fall or other kind of event of this kind. Usually,
it's also because people when falls have also a different combination of rotation and the combination of the different signal from the different sensors is very, very relevant for distinguish this kind of.
We also tried, for example, putting the smartphone into a bag and for yes. Also in this case, it is not. It is distinguishable in this case, because there is the kind of signal is typical if the sensor is a unique system with the body of the person. So.
And these measurements are dependent on the type of phones you use? I'm using my iPhone.
Yes. We tested only on 3 smartphones and on Android system, with Android system, but there is some changes between models and also for the probably there is different sensitivity of the sensors.
Well, these sensors have some technical specification, and so results may vary if you don't use the same kind of sensor.
Yes, because obviously we detected based on the recognizing the situation, so we mainly we used the 3 models of Samsung. 3 different models for detecting for the 5 people used the 2 kind of mobile phone. The part of 10 people for they used these 3 models, but also other, but for detecting. In any case, only Android, because the iPhone, the smartphone is implemented only on Android at the moment.
Please, can you treat a large data in the under limited storage problems. Smart one have limited resources.
Yeah.
How to create a large data collected from sources?
Yes, because this part is linked to a platform implemented by us for managing data, and we have a large social network platform this is linked to, because they are two different platforms. This platform is mainly implemented with HSO2, is an open source, and there is and the data are collected to our framework. We implemented in the past years a framework named Plax, part of our knowledge and the services sharing, and the data will be collected into this because we are starting with two large applications involving family doctors for testing with real users, real patients, this kind of. In particular, it is important also to detect false positive, because to avoid too many alarms not justified. Because, for example, in the table there are situations in which all the false are detected, all real false, but we have also situations in which changing the minimum and the maximum thresholds, but in that case we have many positive, false positive.
So you have another question?
Yeah, Fernando, very nice topic. I was wondering, when you were presenting your experimental results, well, you had some false positive, false negative, and your accuracy was like 90%,
97% of
yeah. And I was thinking about something that would be beneficial for the community.
Yeah.
Which is, okay, we cannot reach 100%, but probably from our observations, like what you are doing, you can tell us if we add some sensors, we can go beyond, let's say we can reach up to 99% by adding just 1 or 2 or 3 sensors in order to fill the gaps. And I think that it is interesting if one thing is to publish the data you are testing, to share the lessons about what you are seeing, observing, and according to you, what kind of sensors we have to add, mix, I don't know, in order to increase this the performance of the whole system.
Yeah.
And like this, at least we can reuse, and probably it will be faster for the future researchers to go ahead with this.
Yeah.
Probably also environmental sensors combined. Useful.
Because I don't know, most of us we are working on sensors now, and probably in a more individual way. But if we can think about sharing our data and lessons, probably this will allow us to go ahead faster and faster.
Yes, we think to start in a few months for this large experiment. It depends on the different priorities, because but I think that in 2-3 months we will start with the large experiment, because mainly in this moment we have to link the two platforms. The platform that take data from sensors, and the platform that manage the community.
All experiments were done with people working, right?
in different, they simulate the fall into on the Cappettino. Yes, on that typical for gym.
The same if the patient is running or jogging or even in the bike. It's the same results, or
yes, they simulate because it is very important to detect the face. Yes, the difference because it is strange, but there is that yeah.
Okay.
Yeah.
Well, thank you. No, I'm sorry.
Yeah, just interested because the recent Garmin bike computers have a crash detection feature which looks a bit similar. So it detects the acceleration, and also, of course, you're moving on the bike. Of course, so you know the GPS speed, and if it's 0 and the impact is detected, it can automatically call a predefined phone number. So it would be interesting how your detection compares to that Garmin one.
Yeah.
Is the proposal that Richard we can combine with different experiences.
Yeah, that would be interesting.
Well, thank you very much. I think it's the last one, right?
Yes.
Okay. Well,